All right. Doing another live stream. Let's see.
How long do you expect it to go?
Steve is asking me from the other side of the room here how long it's expected to go. I don't know. We'll see. Maybe for an hour and a half, something like that. Not super long. I'll probably be hungry at that point. Okay. So let's see. Right. So what I want to work on is this very subtle but annoying discrepancy in our rendering. And I noticed this when working on the flame graph because originally things didn't seem to be properly lined up. So let's have a look at that first. So if we look at our flame graph and we remove this stroke here and we just say we create a rectangle and we fill it, and this is just a rectangle that spans the entire size, you would expect it to just fill the rectangle all the way to the edge, but it doesn't. And so you get this, right? You get these gaps in between them. And these gaps exist even without us rendering them. So, or even without us specifying them. So there's basically no gaps that are in any of these coordinates, right? Like the y, for example, the y position is the height of each level. So we call these things levels. Is the height of each level multiplied by which level it is. So the 0th level will start here, and then we go here and here, and so on. But then the y of the height of the box is also the same amount. So it's not like, we add a padding here, or we subtract a padding here, or something like that. We should expect this rectangle to be completely filled without any gaps in between the different levels. So where is that coming from? So what I have here is another example. It's a test that tests our shader primitives, and Hernan made this. Hernan worked on Zaplib before it was called Zaplib at Cruise. And what we have here is on the left-hand side we render this scene with Zaplib, and on the right-hand side we use the traditional 2D canvas that the browser provides you. And we make basically the same calls in both places, and things end up rendering a little bit differently. So, that is it's probably a goal to make these things render in exactly the same way, pixel for pixel, eventually. We have some ways to go, right? Like these circles look pretty similar, but then here it already starts rendering a little bit differently. And maybe we don't need it to be exactly perfect, but there are some discrepancies, and some of them can be quite confusing. So the one that I noticed is that if you look at this entire grid already, like the grid just looks a little bit washed out compared to this grid on the right here. And if we get our friend the digital color meter, here you can see this. Like this border has like a perfect, like nice straight line, but then this one is 2 pixels wide. So what I'm suspecting is happening is that we're drawing this exactly at the pixel border. So we're kind of drawing in between those 2 lines, right? In between those 2 pixels. And so it will render that as a 2 pixel wide line where the pixels are a bit washed out compared to, because the colors, we draw it with the same color here. And then you can see the same thing happening with this rectangle, right? So maybe we should just shift everything by half a pixel. And that might just fix everything. But I do want to understand sort of where this is coming from and what would be the right place to fix this at. So we can run the same example natively too. And, ooh, that is interesting. Let's see, we get the same behavior here with this rectangle, but for some reason the horizontal lines seem to be gone. Did I change anything in the meantime? Or maybe it's just, yeah, actually rendering it slightly differently. Let's see, I don't think I changed anything yet. Oh yeah, we commented that out. Okay, and I made some changes here. Okay, so let's undo that, and let's just go to the main branch again, because we don't really need to look at the flame graph too much for this for now. So this is the first fix that I made. So originally this was made to be run using Ceph, or what we're now calling Zaplib. But the whole Zapium Ceph thing doesn't run on my machine yet because I have an ARM machine, a MacBook M1, and that doesn't currently work. So so here I made it so that it actually runs in the web browser properly, right? So we have it run here. And so the first thing that I checked is like, oh, like does the canvas actually properly span the entire body? And it seems like yes, it does, and so on. But then, yeah, like since it's also kind of happening in a native build, it's probably not at the WebGL rendering level that we're encountering this. So in any case, let's first commit these fixes here so we can run it on the web. Let's make a branch here. Fix shade, like, I don't know, 2D rendering blurring or something. Okay, so the first fix is make test shader 2D primitives work on web. It was only working on Ceph before. Okay, good. Right. So yeah, we can look at this on the web. We can also look at this natively. And it is interesting why we don't get those horizontal lines. And maybe at some point we also want to make Zapium work here, which might not be too much work. Oh, this is interesting. There's even some discrepancy between the rendering here and the native one, where here we don't get these horizontal lines either. Okay, so the horizontal lines are just generally not really working here. That is pretty interesting. And also these lines seem to be a little bit sharper here. So if we look here, like this seems to be correctly 1 pixel wide, and here they are 2 pixels wide. Right, and okay. I don't know exactly how we do these. Also, this looks weird. Okay, I don't know what is up with this column. Like, we don't have this column in the 2D canvas. I don't really remember what we do there. Okay, but we at least have the same issue sort of happening here with this rectangle. So let's see how this rectangle is being drawn. Let's see, where is that? Right, in here. So we have these different primitive types, and primitive type 1, I think, is our rectangle. Yeah. Oh no. 0, 1, 2, 3. So this number 3 here is the rectangle. Right. And we get the size. Okay. We do a bunch of funky stuff here. I don't know if we should really be doing it that way. Like in most places, like we don't we don't draw it like that, I think. Why do we multiply it by the DPI factor here? Normally you don't have to do that because, oh, I see. This is, yeah, okay. I think I remember this. So if you look at maybe, let's look at our standard shader. Right. So normally you would do the F viewport, but here we do viewport in pixels. So we actually take into account, yeah, okay. That's okay. And then, right, we get a point which is sort of the, like here, and then we draw sort of the half of the size of this wider rectangle. Okay. Let's see. Right, so first of all we draw some text, and then we draw these bounds. So this is our size. So these are all like integer values, right? 20, 40, 600. We draw the grid. Oh yeah, and we draw the grid with these draw lines 3D. So maybe the fact that we do these 3D drawing, which is like, I don't know, it's a little bit of a complicated shader. Maybe that's why we're not seeing the horizontal lines on the native version. Okay. And then we draw the individual primitives, and yeah, we just, yeah, there's no half sizes here or anywhere. Okay. So I guess the first thing that I'm wondering is like, yeah, maybe we should just offset everything by a little bit or something. Like how does it work if you just want to fill in 1 pixel, right? What are the coordinates of that? Like what is the behavior that you would expect there? Like if we want to draw the pixel at 0, 0, like in the top left corner of our window, I would expect that you would say that it has like a position of 0, 0, and then a width of 1 and a height of 1. But is that quite right? What would happen in the canvas case if you do that? Yeah, what is sort of the behavior that you expect here? Right, if we say we draw a rectangle, yeah, like what if we just don't do any of this, and we say we draw a rectangle at 0, 0 of size 1, and then we fill it, what's this? Oh yeah, this is basically the syntax for that. Like that's not completely, as crazy as it might sound, that's not completely obvious to me. Okay, so, what? So, there are like, we get actually multiple pixels. Is this a resolution thing or something? Like, what is going on here? Oops. Oh yeah, this is a known issue. Okay. Right. So the width and the height match here, that is good. Right, and so if we, instead of this, say, this is something like this. Oops. Okay, that is also not quite what I would expect. So we get it to be multiple pixels wide here. What if you do a rectangle that is just all zeros? Then it goes away. What if we do one that is like 5 wide? Okay, right, so we have 0, 1, 2, 3, wait, I can't count this way. It has to be 1, 2, or 0, 1, 2, 3, 4, and then this is 5. So this is actually 6 pixels wide. What if we do 4? Now we get 1, 2, 3. Okay. So it's always like one bigger than what you would think. Okay, that is interesting. So you can't. It seems just with cx.rect. Let's see what the documentation says about this. Right. So 2D canvas. Rect. Okay. Okay. It doesn't talk too much about these subtleties. Interesting. Okay, and let's look at this. If we fill it again. Ah, right, look at this. So we said it should be 4 wide. So we do get something that is like 4 wide, but it's actually sort of it's not the proper color at the edges there. That is, oh no, wait, it is 5 wide. Okay, so it does have sort of this offsetting behavior. Is this right? Am I sure that we're not like moving this in a weird way or something? It has like a whole number margin, whole number padding. If we delete this canvas and we just put this canvas sort of without any margin. We get it sort of all the way in the top here, yeah. The width is correct. Yeah, okay. Now what if we, okay, so if we fill a rectangle that is 4 wide, we get one that is 5 wide, but slightly offset. 3, yeah. What if we put it at like a fractional point like this? Aha. So now it's crisp. Okay. So that is its behavior. Right, so yeah, how do we reason about that properly? And then what if we do a stroke instead here? Also, actually starting it at 0, 0 is like a little bit dangerous, because it, like, part of it might get cut off. What if we put it at 10, 10? Okay, yeah, we do get the same behavior. And then 10.5 should do the thing that we were seeing. Yeah. Right. Now this is fake. Well, okay, so what is the stroke size? Is there like a line width? Okay. What if we make that 1? Maybe it is already 1. Okay, it looks like it is already 1. If you make it half, maybe. That doesn't really. If you make it 2. Right. And now it's like, yeah, okay, sure. Right, so this is all subtleties on, like, are you drawing sort of through the middle of a pixel or on the edge of a pixel, and exactly what does that mean? So let's see if the standard has a bit more to say about how filling works exactly. Okay. Let's see. Oh yeah, okay, there's some people who are confused about this too. Also wondering, oh my goodness. Okay, so wait, so we were already translating it. Okay, by half. Okay, great. Right, so if we don't do this, this behavior works as expected. Okay, that is something I was confused about. Okay, so this makes more sense. So what is this exactly? Interesting. Okay, so I guess if we don't do that shift, then it will actually look the same. Right. Okay, so we are consistent with how the canvas works. Somewhat. Like this first line gets clipped off a little bit. That is interesting. So how do we deal with that right now with our buttons and so on? Okay, at least this makes sense to me now. Like the behavior is slightly different, right? Like this looks a little bit of a different color, but okay, on the whole this looks more consistent now. We get sort of, yeah, the same issue in both places. It rasterizes to different colors slightly. Yeah. Okay. How do we do that right now if we render something like the single button example? Because here, yeah, I guess you just don't really notice it that much. Because, let's see, if we do something more complicated like big edit. Let's see what we get here. So, yeah, this line is also sort of like too wide. Okay. Yeah, everything is a bit blurry, isn't it? Like, should we by default offset everything? I mean, people don't do that for the 2D canvas. And then they get stuff like this. Right. Yeah. What size do we draw these rectangles with, though? Let's just make sure that we do draw these with like, oh, actually, we might not be drawing this very nicely. Let's see. Sure. Something like this. So now we get the positions of all the rectangles. Oh no, these are fine integer numbers. Right. Yeah, okay. Huh. Right. Yeah, is this a thing? What is this exactly? Interesting. Yeah, that seems like... Right. It seems like it should only really apply if you're scaling, and we're not scaling here, but let's try it anyway. See what happens. So it's by default true. If we set it to false, then what happens? Oops, let's look here. Yeah, it's still roughly the same. Maybe it looks like slightly different. I can't really tell. Okay. Okay, so we're translating everything by half a pixel over, and then we get a bit more crisp rendering. Or not, I'm still a little bit confused. Let's go back a little bit to what we were doing here. Yeah. Like this, for example. Yeah, okay, so now the stroke thing is precise, but fill, is that? Well, first of all, if we set the stroke line width to 1, then what happens? Right, that is still like this. And if we fill it, then what happens? Yeah, okay, so that does what we expect. Right, and then it draws the line sort of at the border. Okay. Right. So that's still a little... Yeah, so it's like, which one do you want to be sharp? Right, if you set this stroke, now you would have to shift this over to get a sharp line. Right, and you do. Right, so by default, yeah, I think this makes intuitive sense to me. Yeah, and yeah, so by default, if we do this and we set this back to our initial experiment of just filling one circle, one pixel, then this should work, right? Yes. Right. I think this is intuitive to me. This feels right. Yeah, and this means that... oh, that's interesting. This rectangle is still not completely... Huh. Oh, right, this is our thing. So if we bring this back, now this rectangle should be sharp. Yeah, okay, and it is. Yeah. Okay, this seems like the better comparison to me. We just might want to move the grid over by a little bit. Yeah, but roughly this seems correct, right? Like this has a sharp edge, and this does not. But that is, yeah, that seems consistent to me. Okay. Yeah, let's maybe fix up the grid a little bit. So if we draw the grid and we do a line width of 1, could also just make it a line width of 2. Okay. Sure. So that works. But we could also keep it to a line width of 1, and then we just have to add offsets everywhere, which is a little bit annoying. But it's not too bad. Oh, and already here we are, Okay, well, let's see. Yeah, okay, so this also makes it sharp. And what if we do our thing here again? We say cx dot, and then yes, okay, right, good. That's what I would expect. Okay, so I think I understand this a little bit better already. This is sharp, this isn't, and that is completely logical. Now, with that understanding, let's apply the same treatment to our grid lines on the left. Yeah. Okay. Right, so that is here. Okay. Oh. Oops. Okay, so now this also looks sharper. Yeah. Okay. Yeah. Doesn't look exactly right. Like this looks a little bit sharper, but it's not too bad. It is a little bit better. Wait, and did we get the horizontal lines back here? Yeah, we did. Okay, so that's also good. That is good. Okay. So now we have the problem that this one isn't sharp and this one also isn't sharp. Okay, so at least our reference image we understand and it is correct. So now, yeah, now we have this issue. So what I suspect is that this is a very subtle error in our sign distance fields. Ooh, yeah, that might become... This will probably be pretty interesting to look at. Okay, let's actually look at this one too, right? So here, yeah, this is interesting, right? We get this red box here, and then the green line is sort of exactly on this pixel boundary. So you get a little green mixed with the red, and then you get a little green mixed with the gray behind it. And if we look here, it just looks a little bit off. It's not like completely properly mixed with the red here. I think. Just visually it looks... okay, it's hard to say. It is hard to say. Yeah, but this one is sharp. Yeah, okay. Okay, so I suspect that we have like some slightly different semantics here. Let's also look at the circle. So the circle goes sort of all the way to, yeah, this pixel has sort of like the full red color. And I suspect it doesn't here. Right, it doesn't. Well, yeah, it almost goes like a little bit too far here. Okay, so it might just be slightly off. Okay, so let's look at our standard shader and look at how we implement. Right, because this is mostly coming from this this shader toy implementation, and this might not be super precise everywhere. Right, so let's have a look. Or like, yeah, the code is inspired on that. But I'm not incredibly familiar with this. So let's see. Because what do we call here exactly? We go in here and we say we draw a rectangle of this point at this size. And then, yeah, we fill it, or we do a stroke, or whatever it is that we do. And then we return the result, right? So initially all of these values are kind of, yeah, I think the main one for us is this shape value. I think this is sort of, yeah, okay, so let's see what happens if we call fnrect. Okay, that calls box. Right, so we calculate our distance. Yeah, we calculate and see, are we in this box? Yeah, let's just annotate this a little bit better. This is the position. This is the distance, or like the size, really. This S becomes like the half size or something, right? Where's this the origin, actually? No. No, it is the top left corner. Okay, does this still work? Am I not messing this up too much? Yeah. Okay, so let's see. Right, so this is sort of the center point, right? And so now what we do here is we calculate our distance from the center. in each of the coordinates, the x coordinate and the y coordinate. And then why do we do this exactly? Oh, so here we, right, so here, this is our distance from the edge. I think, right? So, yeah, like if the center point is at like 1, 1, and we're at like 2, 1, we will get like 1 out of this, but then we subtract it again, and then this becomes 0. So then, yeah, that might be, yeah, okay, so this is, I think, how we get sort of the edge. Right, yes, that seems right. Okay, so let's say distance from edge. Yeah. Right, so if this is 0, we're exactly on the edge. But, as we saw earlier, we have to compute this sort of with the positions being, there's a difference here, right? Like this position is sort of, in terms of points along the pixels in some sense, right? This is, whereas this position, like our own, this self dot position is pixel centers. So the coordinate system between this one and this one is shifted by half a pixel. So I think that is where maybe this is coming from. Right? We can't just, like this center thing is in terms of, it's offset. It's also in the coordinate system of sort of the coordinates along the pixels, in between the pixels. Okay. So really what you need to do is you need to say, well, we need to correct for that here. I think this is the right place. Or in fact, maybe we can always say, well, our current position is, we can translate it back to the other coordinate space. So when we set our current position for the first time, maybe this is where we transform it into the coordinate space, like this. I don't know if there's a word for this, sort of, the center, yeah, coordinate space center of pixels. Versus edge of pixels, something like that. Okay, I don't know if there's a good word for this. If anyone knows, it's probably no one watching this. That's okay. If anyone knows what the word is for these two different coordinate systems, that would be helpful. Okay, so let's look at this now. Oh, that looks so much better. Okay, except for those cases, but like this looks very sharp now. That looks great. This still looks incorrect. This still looks incorrect. That edge should be sharp. And of course, like, we have all these weird artifacts here, which we will have to look at in a second. Yeah, there might be other things that are sort of in the wrong coordinate space still. Okay. Yeah, this seems like progress though. What does a circle do? Yeah. Doesn't look quite right yet either. Yeah, and this is crazy. What does this look like? Is this exactly the same in our web version? Because we saw some discrepancy earlier. Okay. Well, wait, this isn't right. This one is supposed to be blurry, right? This one is supposed to be blurry. So maybe we're doing another. So it's funny, we kind of fixed, quote unquote, this one, even though it's not supposed to be fixed, and we didn't fix this one. But it should in fact be the other way around. And also we didn't get those other artifacts here, so we actually have like slightly different shader behaviors in those two different rendering targets. That's also not great, right? That is not great. Okay, so maybe we, but at least, okay, like aside from that weird artifact, like the behavior here is consistent, it's just wrong. Okay. But we say here that this is now sort of in the, yeah, like in a different coordinate space. Yeah. Okay, well, let's just keep going, and maybe we'll have to, it's very likely that we'll have to change some things here, right? So yeah, we have the center of our box, and we get the distance from the edge now. And what do we do? And what does this distance from the edge represent exactly? Well, this is I see. Right. So this distance will, be for the pixel that is right next to the edge, or like the edge is in between pixels, right? So you have like the pixel on the one side and the pixel on the other side. So let's say the pixel on one side of it will be like plus a half, and the other one will be like minus a half. There won't be a pixel for which it's like exactly 0, right? Because there's no pixel on the edge right now, since we're now properly computing these values in the same coordinate system. So then, okay, so that seems fine. So then we say, there's like this, we have this distance in both directions, right? And we take the minimum, and we take the maximum. Why are we doing that? Oh, yeah, okay, so this is just, this is some clamping, right? So this is like negative, this is like the neg, really. This one can only be negative. And this one can only be positive. Right? Yes. Yeah, and I think they're just trying to avoid, you know, doing if statements here. Basically, they're trying to avoid branching. Basically saying, yeah, we take the maximum of these. And so let's see. So if the distance is positive, that really represents like how far outside of the box are you in any particular direction. And if it's negative, that means like you're inside of the box. Okay, sure, whatever. That this seems fine. I don't fully understand this calculation, but let's at least, yeah, let's just move on to a little bit further, and we might want to backtrack there. Okay, so then there's this scale, which doesn't really matter, and then we say, okay, we are now in this shape, right? And we're always sort of like in the minimum shape. We're in the minimum distance field. How does that work exactly? Right, okay. Yeah. Yeah, and that basically means like if we're negative, we're in whatever shape we're creating now. If we're positive, we will fall outside of it. But there's also an interesting border case, right? Like what if you're just like between 0 and negative 0, negative 1. So then we do the fill, and I suspect that this is where the next thing goes wrong. Let's see. Fill, yeah. Right, so we calculate the amount of blur, right? This makes sense. It's like if we're fully inside of it, then no sweat. We just color fully. So in that case, f will be 1. But if we're sort of in this border region, we will get a blur. And then we do some clipping maybe. That's not really relevant for this right now. And then this right color, yeah, basically multiplies with so it does like what is it called, like pre-multiplied alphas or whatever it is. Well, it applies really this alpha or this transparency. This is really the opacity, right? I think if it's 1, yeah, I think so. Okay, so this calc blur is what is interesting. And then also you can see that the same calc blur thing is being used for the stroke thing. And that is like, that might not be quite right either. Or maybe it is. Okay, well, let's see. Okay, this is a private function. So yeah, we get our distance essentially. And this distance, right, so let's think about this. We're in the coordinate space where we're in between pixels. But we need to calculate for a particular pixel. So that means that our distances, basically if we're distance half away, right, from this border, yeah, maybe this is, like maybe when we're thinking about distances, this is not the right coordinate space anymore to really think about it. No, it doesn't. It does seem probably okay. Well, let's see where it goes. So, when we're sort of half a pixel away, that's like we're smack in the middle of this pixel, and we need to sort of fully color it to the current color. So this is probably the moment that we need to adjust things a little bit. So, because I think that this thing assumes that we're, yeah, like in a coordinate space where we're like in the center of pixels. So I suspect that if we say W is like minus equals 0.5, that corrects us into the edges of pixels again. Let's see. Okay. No. No, that's not quite right. Well, there's also this stuff. Okay, so that is not really anything. What is this? Okay. What if we don't want to do this anti-aliasing stuff? Let's see what this looks like. Yeah, this is not right, is it? This is not right. Okay, let's go back to how we started with the incorrect coordinate spaces. Right. So we could also go the other way around and say we adjust everything into the other coordinate space, right? So if we go in rect, so if we have a rectangle, if we have this box, then this is in the coordinate space. Yeah, and so if we add 0.5 here, then that should have a similar effect. And then maybe some of the other things, yeah, are made in the assumption of the other coordinate space. Okay. Okay, no, this also works out in the wrong way. Oh boy. Okay. So maybe the filling is just not quite right. Okay, well, let's go back to the other coordinate space that we had here. Okay, so everything is on the edge again. Okay, let's just see how filling works, right? So we say, yeah, really what we want to say here is we want to get this f to be 1, I think, if we're in the shape. Let's actually do something, right? Like let's say, let's f equals 1, sure. And if no self.shape is bigger or equal than 0, then f equals 0. Just, I think that is interesting to see. Okay. Right, so now we get like sharp lines everywhere, which is not quite right here, right? And it's also just not quite right in general, because what we said is that if it's bigger or equal to 0.5, but really it's like, you know, you should do like something like this, right? Because of like rounding errors. If it's, wait, no, I'm still confused. What if we just always set f to be 1? Yeah, okay, then it just renders it full. So f equals 1 is like this, so this is really like opacity. Let's call it opacity. And it's like if you're outside this range, yeah, or like more like this, right? Then it should be 0. So this should give us a similar result. Whoops. Yeah. Right. Right, but now it's not very nicely anti-alias, right? Like this is all jagged lines. And this one is incorrect. Okay. And this 0.5 is, yeah, to account for the different reference frame. Okay. Okay, but we can do something similar here, right? We can say, whoops, if w is bigger than 0.5, sure, and otherwise return 1, minus 0.5. Yeah, okay, so that has the same effect. And then what we're saying is we're going to modulate this a little bit, right? If you're just a little bit outside of it, like what are the possibilities, right? Like w can be 0.5, or it can be 1.5, or it can be 2. Like, right? If we're just calculating these things with integer values. So Ooh, this is hard to reason about. Yeah, so by the point of 1.5, it should be completely gone, right? So if you say yeah, but then when it gets smaller, right? Okay, so let's think about minus W. So that basically makes it like this. Something like this, right? And then right. So if you, yeah, let's just try that for a second. Should we have done this? Yeah, no, that doesn't make too much sense, does it? Okay. Ugh. Right, so what if we say we return clamp W, but we want to say yeah, what did we say earlier? Yeah, it's a distance, so if the distance is bigger than minus 0.5, then we return 0, otherwise we return 1. That is what we said. Right, so because minus means that you're inside, yeah. No, wait a minute. No, is that right? Let's think about this. Okay. No, that is not right. Because the top leftmost pixel that we want to be colored in, or like, yeah, like let's say just the x-coordinate, the leftmost pixel will have distance 0 because we already translated it here to be on that edge. So it's almost the other way around. Wait, let's look at what this looked like again. Yeah, so the problem is that the pixels on this edge, wouldn't it be nice if we can have a debugger for each pixel to show what the pixel shader evaluated to, or like debug through the pixel shader. That would be great. But yeah, if we think through it, it will have a distance from the edge that is 0 at that point. So this thing will have a length that is purely its y coordinate. Yeah, okay, so that should be 0 then. Yeah, df in that case should be 0, I think. No, wait, okay. This should be a plus if we're yeah, this should be a plus if we're translating it to that coordinate space. Yes. Yeah. Yes. That one is wrong for sure. But that of course doesn't really change anything because we're just translating everything by half, by 1 pixel. Okay. But now, yeah, pixel 0, 0 in our new coordinate space will be position. Yeah, okay. Right, right. Yes, and then yeah, and then we will, so now shouldn't it be the case that if we subtract like 0.5 here, no. Yeah, okay, we just got, yeah, and we're just translating things back and forth. Okay. I'm still not fully grasping it, I think. Okay, so right, but this should now be properly be like, yeah, for that pixel in that corner should be Right, so what we should have here is not entirely, because basically no, this is not right. So if we have a pixel that is going like, I think we have to change it here. Okay, I mean, maybe not. So if we have a pixel that is, like, when should it be exactly 0? That is if you have the pixel at the distance at -1.5, or at +0.5, right? +0.5 it should be 0, at -0.5 it should be 1. So, right, like, is that right? +0.5 it should be 0, so at +0.5 this becomes -0.5. Right, so we should add this, yeah. Clearly I'm still not thinking about this right. Okay, I think I have it wrong somewhere upstream. What if we just do something like this? No. The minimum, I think, of, yeah, and then let's not worry about this. Okay, so maybe that's the inverse of what we want. That's a cool effect. Switzerland's flag, it's a big plus. Am I getting my signs wrong or something? Wait, should this be the, no. Okay, now I'm just trying stuff. Yeah, it should be the max, because if one of them is outside, then you are outside. Yeah, okay. Okay, so this behavior is still roughly the same. So what do we get here then? So sure, Yeah. And let's make sure that our rectangle size is actually like a multiple of 4. Or, yeah. Where do we do that? Here. Okay. Yeah, that seems good. Okay. Okay, so this field is roughly right, I think, then. Okay, so we're back here. Let's maybe just do something like this. I don't know if this is going to be helpful. No, this is inverted. Okay, sure. Right, and then, oh no, I did get it right. Sorry. No, wait. And then there should be 1. Okay, yeah. Oh. Okay, that doesn't seem quite right. Or does it? Yeah, no, wait, this is good. Because we do expect 1 pixel to be yeah, we basically expect this to be like -1.5, this to be like -0.5. Okay. Alright, I'm going to do some more fiddling with this, but this is enough for the stream. I'll get there.